Hey everyone, my name is Betsy and I'm a lead analyst for a toll road operator, and I'm excited to introduce Traffix. It's an AI-powered platform that helps transportation professionals understand why mobility patterns shift and why events occur. So starting with the bigger scope, so in US there's over 4.2 million miles of public roads, and this equates to 285 million registered vehicles traveling 3.3 trillion road miles annually. And it's so important that the federal government even maintains a budget to improve this system of 147 billion, with 104 billion exclusively just for land transport. And this is not even including all the private companies that manage logistics and infrastructure where the value is in the trillions. And to keep all this going, the US labor force in transportation is about 10%. But let me bring it a little bit more to the personal scope. So I know everyone here probably owns or orders packages. So in the US alone, an average person gets 66 deliveries, and I bet you really care if it comes to you on time. And then also, the average American spends 54 minutes commuting every single day, equating to 225 hours annually, and that's just for work, with an average of 2.43 driving trips per day, including work and leisure. And the transportation company INRIX has indicated that the average US person loses 43 hours a year just from sitting in traffic. And actually, if you're in the DC area, it's 100, which is very depressing because that's where I live. Um, Also, it's not just an inconvenience by wasting time and increasing stress levels, but it also is a major cost. So overall, the U.S. Led the congestion led to 4 billion hours lost and over 74 billion in wasted time and productivity. So let's understand the traffic data challenge. So the transportation ecosystem involves everyday drivers, road operators and safety agencies, city planners, construction teams, logistics and business providers, and then data and traffic analysts like myself. And we're all trying to understand why traffic and incidents occur so we can make better choices that will improve safety and efficiency on our road networks, as well as save our time trying to analyze it. But the problem is transportation data is very fragmented, inconsistent, especially because a lot of it comes from the government. Since the data is often scattered across agencies, sources, technology streams, incident logs, weather feeds, even social media, it's really hard because they're all different fragmented pieces of the story. And I actually didn't find any applications out there on the market that really tells the story holistically. They're usually very numbers based, like Intrix or Google Maps. So in essence, we're very data rich but insight poor, and because of that, a lot of organizations are very reactive and not proactive, and because they're spending too much time trying to see what the problems are without preventing them. So that's where Traffix fills the gap. So unlike generic AI systems, Traffix is the AI-powered storytelling agent built specifically for transportation analytics. It automates the hardest part of their job by explaining why travel conditions change and gives recommendations to mitigate these issues by connecting structured traffic data with unstructured context like news and weather and events. So analysts can simply ask, why was congestion higher than normal today? Did construction affect travel time reliability? What can I do to help this problem? And then Traffix can give you clear evidence-based insights to you directly. So let's take a look at this application. So this is the application itself. The way that it's split in the UI is it gives you both quantitative and qualitative. So you have a lot of numbers on the left side, and then you have a analyst chatbot on the right where you can ask questions about the data on the left or just ask questions at your leisure. The first thing is you can select your region as well as your time period. We're going to start with the left side first. So we have our ban, our key metrics, KPIs that people usually want to know right away, as well as we have a network map here that is showing all the different incidences on the roadway. It's actually clustered by the type of incident. And you can click on these clusters and they can actually drill in. For example, if you highlight over this, it tells you the breakdown of what's located in this area. And I can see that a lot more here are disabled vehicles, and you can keep clicking into it and see the problem areas right away, as well as you can highlight specific incidents and see their details. And if you want to know more about it, you can ask about this specific incident ID in the analyst panel. Scrolling down, there's also insights and analysis cards here that feature specific things that you might be interested in, such as anomalies, popular problem areas, weather conditions. And each part of this has its own view details button where it gives you an AI summary pulling from the backend to tell you how these specific factors might have affected traffic during the custom time range you selected. Going down here is analyst recommendations. So this is probably one of the key, I guess, things that make Traffix shine is it's telling you, it's looking at all the different data we have a Postgres database in the backend, as well as we're pulling in from all articles and so on. And pretty much it takes all that information, it tries to develop patterns using historic data and so on. And it can give you three key highlights of places that you can potentially do correction and mitigation techniques. So for example, this one's looking at Prince William. It found that there was a lot of construction issues, construction zones that also had accidents, and it gives you some suggested actions of things you can do specifically in that area to try and mitigate the problem. And you can even do a full analysis and see a remediation plan. This one looks specifically at disabled vehicles in a certain area and where they're happening at a certain time of day, and then it gives you suggested actions to try and prevent that from happening. Lower down here, you can see that there's latest news and updates. These are all clickable articles that you can click on right to, and a lot of these are the ones that are actually powering in the back end, but it's just nice to see. And then down here is just a bunch of different charts to kind of for the data lovers out there. But to the right over here is the AI-powered assistant. So in this case, you have three different options: high level, quick insights, or deep research. In this case, you can ask different questions of varying levels of detail, and it affects the workflow in the back. But in this case, I already ran one on deep research, which is asking where is construction events and how can I prevent them? And then it gives you a pretty lengthy summary of all the problems and potential factors that cause it and how you could potentially mitigate construction and so on. And then you could easily click and change through those different detail levels. And I'll just ask a quick question here. Why was traffic below forecast? And these two are a little quicker than this one here. And here it gives you a snapshot telling me the percent below forecast, the potential drivers. This one's talking about the ongoing government shutdown that's happening in the US. And then it just goes through some other activities that might be causing your problems. Um, So going back to the PowerPoint, so how traffic really works. So in the backend, traffic is pulling from a bunch of different sources. I'm pulling specifically from Waze using New Search from Tavily, and then also RITIS, which is a regional transportation institute from the University of Maryland, where I can get a lot of different traffic and congestion data. And then I also am pulling from synthetic traffic data. The dashboard and automated insights portion pulls off from that to create what you see in the UI. And then the chat portion works here, where you have the user ask a question and a query, like such as why did traffic spike in the morning? And then it goes through the different routes. We have kind of a two workflow approach here because this multi-agent loop here, which is a research agent passing to a writer, an editor, and evaluator. It doesn't always have to be used for every single question. A lot of times you can have a simpler question. It's a lot shorter process, which is cheaper and quicker. So that's why we have this approach. And then over here is the more in-depth application architecture. I'm not going to go through all of it, but in general, the different colors represent the different stages. So you have your user layer, you have your front end, here's the back end orchestration area, you have your LangGraph multi-agent workflow, and then your data and external systems here. And then this is the tech stack. And then I'm just going to end on this one. So just to end and wrap up here, with Traffix, the transportation analysts and planners can save hours in manual investigation each week. And as we know, time is money. And you can generate consistent, clear reports instantly. You can identify causes and recommendations behind the trends, not just the patterns. And you can deliver faster insights to leadership and the public, which will often lead to more proactive pursuits. And this impact is real because it can lead to safer roads, faster detection and prevention, smarter investments, so focusing resources where they matter most, and more efficient cities, less congestion, reduced emissions, smoother flow. And as far as things that I want to concentrate in the future on, I want to add in more personalization and modular reporting, role-based dashboards that are focused more towards analysts, planners, or executives. I want to adapt a little bit more on the mapping. I know right now it's just doing clustering on incidents, but eventually creating some sort of digital twin model where you can maybe simulate and also have places where it predicts where accidents are going to happen, expanding the data set, and then adding in some more transparency so that it can be a little bit more scalable and understandable to people. That's it. Thanks. Hey everyone, my name is Betsy and I'm a lead